discussed about map function and two ways of applying map. How to apply map using a normal function and how to apply map using lambda functions. The idea is to understand both approaches of passing method to map function, these higher order functions. So generally, we had already discussed. So these higher order functions takes a function as parameter, and that's what we had discussed in the last class. It was a very detailed session. So, so that's about that one. So we had already discussed about map. So one more small example is just taking one example, iterating here. If you see here, how to take multiple lists and how to apply iteration on multiple lists and perform addition on that elements of two lists here. You can see here. So let's do that here. So this is another example with the map with multiple lists. And this is the syntax. What is that? Some map of func comma. So how many ever lists we want, we can pass that many lists. We had discussed this yesterday. To a map function, we can pass one list or two lists or three lists. Any not just list, iterable objects. That iterable can be list or tuple or set or anything which is needed to apply this map function. But one thing is here, all lists must be of same length. So this is one simple scenario, but there is next one. Generally, having same length is preferable. Maybe you can try with different lengths of lists and see if it is really working or if you have some issues. Okay. And again, number of lists must match needed by func here. Okay, that we can discuss, see with example. So now if you see this is the example. Just take, let's apply this now. Take two lists. Simple. This is, you can see here. I don't think with the discussion what we had yesterday, applying this is very simple here. What is it? Declare two lists, L1 and L2. Let me just open this and you can close all this. Right, you can then higher order underscore functions. And that to take to map with the multiple lists. That is the example we are discussing here with multiple lists. And also simply what we can do here, some result equal to, we can directly create it, not a problem, map of some. We are just trying to add elements from two lists. So lambda space x comma y. We are taking two parameters. X come from first list and y come from second list, and then we are trying to add both elements. One from the parallel elements from list 1 and list 2, and we are trying to add them, saying x comma y. And to this we need to pass two lists, L1 comma L2. That's all. So and now finally you can do what? You can print result. And we had already discussed, right? If needed, we need to convert it to list. Let's see. Generally, this by default returns map object. That map object, we can convert it to a required data structure. It can be list or tuple or set or whatever you think that is best conversion. Okay. So that is the idea, friends, here. So we can just simply create like this. Now run this example and see the output. See, perfect. What is that? 1 plus 7, 8, 2 plus 8, 10, and 3 plus 9, 12, and 4 plus 10, 14. So finally, you can see that we try to apply two lists in a map function and apply that logic with lambda function. And finally, we got some output here. This is the transformation we are doing on two lists. So this is the output we are getting here. So this is a simple idea how to apply map with multiple lists here. Okay, this is the idea, friends. Next one, we have to talk about filter. So once we discuss map, another important thing here is so we can jump to the filter. Just a minute, friends. Yeah, filter function. Map is clear. We had discussed about map. What is map and functionality of map? How to pass one list or one iterable to map and multiple iterables to map, and how to work on that. We have seen examples on every scenario. So that should be very clear for all of us. Next one, filter. Even the syntax wise, we don't have big difference, right? It's a very simple thing. So filter is nothing but same thing. Whatever we do with map, we do with filter. But the difference is map will try to check, iterate each element and apply transformation on each element. You got it right, friends? So that is what filter does here. Got it right? Sorry, that is what map does. So what map does, iterate each element and apply a transformation on each element. Like, if you have some list of values like 1, 2, 3, 4, 5, you can add it with some 100, or like we can add each element by 100, or and we can change that value or update that value. Similarly, what filter does here, even it does the same, but the difference is we apply a condition here, and that condition for each element, if that condition is satisfied, true is added, else false is added. So that's what filter does, because filter, as name says, apply a condition check. So what it does here, filter runs through each element of iterable. It can be anything. Iterable in sense, it can be a list or tuple or set or any of these data structures, even dictionary. And it applies function to each element of iterable, same like map. The difference is map try to apply transformation, filter I try to apply a condition check. And what it does, if a function returns true for that element, then the element is put into a list. So if the condition is true, following that condition, element is added to a list. So that we check with example. So, and finally, what is this? This list is written from filter in versions of Python, and of course. So finally, the whole object is written as if that whatever the results we try to store in implicit iterable object. Okay. So that is written back, and we try to, again, we get a filter object like how we had map object yesterday, which is a iterable object with all that results accumulated in that, applying that whatever the condition we try to apply with the iterating that lists are iterables. So, and you can see here in Python 3, filter runs an iterator which must be cached to list. This is, we can see this with example like map object here. This filter returns iterable object. Even map is iterable object internally. Even filter is iterable internally. That we see an example. If you look at the example, it is very simple. And even the syntax is same as almost map. So instead of map, we replace it with filter. That's all. We don't see big difference. But the difference we see here is when you are applying map, we apply certain transformations. When you are applying filter, we apply certain conditions. Okay. And if that condition is satisfied, so whichever value is satisfying the condition, those values are added to the filter. That's how it works, friends. So anyhow, let's just apply a quick testing on this. See here, this is the example. This is a list of numbers with so zeros, positive numbers and negative numbers. Right? I don't think we have negative, zeros and more positive numbers. Right? All 4, 7 zeros and all that. So the idea is we are filtering uh, this list excluding zeros. Okay, wherever there is zero, we should avoid that, and remaining things we should add to the list. That is the idea. So here you are just doing the same thing. What is that? You are applying filter. You are just checking if it is applying a condition. And if it is satisfying, that element is added to the list. Anyhow, let us take this as example and let us apply filter. So take this. These are all simple things again. Take a filter example. Okay. And then take one list here. So now you can take a result to our filter result just for difference equal to. You can apply directly a filter, and then what is that you should do? We should pass our iterable to this filter as second argument. What is our first argument? It should be a function. It can be a regular function or a higher order function, sorry, a lambda function. It's up to us. Which one we should apply is up to us, friends. So if you want to apply a regular function, apply regular function. If you want to apply lambda, apply lambda. So what is the idea? We should filter out on all this. We'll do one thing. Let's apply two approaches. First approach, anyhow, we started with lambda, right? Let's do that. Maybe in the second approach, we'll see how to pass a normal function to this filter and then how to apply that filter on normal function and list together. So the idea is x colon. And if anywhere we present we have 0, we should avoid it. X not equal to 0. And convert this to the whole thing to the list here. So just run this. And finally, what you have to do, print off a filter underscore result. Okay, and right click on this, and you can see perfect. So this is a simple way of applying filter. The difference is if it is a map, it applies a transformation, a logic is applied. If it is filter, a condition is check is applied, and based on that condition check, values are filtered, and a new list is returned based on the condition we apply. Whichever value satisfy the condition, all those values are written into a iterable object. Right? And then we convert it to list. Finally, we get output like this. Okay, if you don't apply list, what happens? What is that we get? Let's quickly check it once. So just for quick check, quick testing purpose, see here, we get filter object like how we had map object yesterday. We get a filter object here. And if you want, you can iterate this. It's not like, so we need a conversion to the list. If you think, so you can directly iterate this filter object. Else what you can do, you can apply a conversion here, list of something, okay? So like this, and then you can just, it's not like you need to convert to the list. If you want, you can convert to tuple or something, whatever you think is needed. Okay, this is one scenario. Suppose if you want to apply a regular function, so scenario 2 or type 2 here is, what do you do here? You create a regular function, add of something, you take a parameter colon, and then you say return x not equal to 0. You can apply many things. It's not like it should be this particular logic. Based on the logic, you can choose what is that condition you should apply. You got it, right? And finally, what is that same thing? Here you copy these two statements. Okay, and this is another approach. This is what we are implementing with lambda. And the second scenario we are implementing with a regular function. Just showing you how we can do the same. Just take this add here and just replace this lambda with add here. And same thing happens every time loop iterates. If you want to debug, just put a debugger and test it. Then you understand how this process is happening, even here or here, anywhere. Okay, you can test it. Already I have shown you how to debug this higher order functions. Okay, finally, what is the point here? Just change this to filter result 2, and then run this, and you can see the same output. We have seen similar, I mean, exact output in two scenarios. So this is the idea about filter, friends. So I got it right. So just keep practicing and applying. Definitely, these are all simple things to understand. Only point here is, so we are understanding multiple things. One thing is how to pass a function as parameter, that to a regular function is one scenario, how to pass lambda is as a function, as a parameter, that is second scenario. And now all this examples gives us the importance of lambda, because we're just passing a function itself as a simple parameter. That itself shows how useful lambdas are. Okay, that's fine. So now we are done with the map, we are done with filter. Okay, now next one. Map is over, filter is over. Let's try with what is it, friends? Maybe you can try these examples. We'll share this PPT if you want. Quickly check this, because once you understand how we apply filter, we apply in the same way on any scenario. So the way we apply would be same. So you can try these examples, that gives a little bigger idea. So next after that, this is even check. If you want, you can give it a try. So instead of this, we just replace it with lambda. If you want, I can just quickly show you, but this is a simple example. You try this. Rewrite this example with lambda. And filter elements of a list. This is a simple again. Negatives and positives are there. If you want to get all negatives, just say greater than 0. If you want to get all negatives, just say x less than 0, x greater than 0. And you can see the output here. Looking at this, you understand how simply we can apply this filter. Okay, friends, this is the idea. Next, after that, reduce function. I'm moving to the next one. We'll share these examples. You can give a try, test this, and you can clearly understand these things. So now what is reduce here? Reduce is up, see whatever map is doing, so or filter is doing, even reduce does the same. One difference is map and filter are directly we can import from the that APIs can be called directly. But this reduce function, we have to import from some built-in thing called functools. So this functools has this module has this reduce. We have to call reduce from functool, and syntax is same. We don't have big difference in syntax. Same like what is that function and iterable and then all that stuff. And finally, simple reduce. Generally, when should we apply reduce? Suppose you have a group of values. This is very much important. You generally apply this in PySpark, right? Reduction. You have generally, mappers and reducers, right? There is a scenario of map reduce, generally when you go to the big data. So mappers try to divide data and try to what they try to assign that chunks of data, something that's what map does. What reduce does, so reduce combines all these chunks and finally provide one result. That is what reduce does. So finally, the way we apply reduce is almost similar in PySpark or map, that big data map reduce. The kind of reduce we apply in map reduce is a similar logic is applied here as well. Reduction means when you pass group of values, it converts all that group of values into a single value. That's what reduce does here, friends. Okay, we'll see that with example. That's all. Very simple thing. So this is very simple and easy to understand. So what do you do here? Let us take the example. Okay, so this is the syntax. So one thing is we should import this functools. That's all. Just what reduce does, same thing, same like what map is doing, reduce filter is doing. These are something higher order, have a function as parameter. That function can be a regular function or a lambda function. Okay, and then we do have iterable here, and on that iterable, what we do, we apply this function. Every time internal implicitly this iterable is executed, and every time it is executed, one value is passed to this function, and we do whatever operation we should perform. Okay, so this is what happens with reduce. What it takes, reduce will apply function to each element in iterable along with some so far. and create a cumulative sum of results. Means that's what means group of values. It will try to convert into a single output. So that's the idea. So it will reduces multiple values into a single final uh, consolidated result. Okay. If you look at the example, you understand it a bit better. So one thing is just you apply this. So when you are working with filter, let's take an example. Sorry, with reduce. First, make sure you import reduce from this functors. Maybe I'm just sharing that also with you. I'll share this example so that you can choose that. From functors, import reduce. That is what you should do. Okay. Next, after this, second thing is let's apply reduce here. What is that here? Some reduce underscore result equal to what you have to do for reduce. So generally, this takes two parameters, reduce function. So take reduce directly. To this, you take a lambda if you want. You can choose lambda or regular function, whichever you think is best fit. So generally recommended, better go with lambda always. Here for getting that difference, we are trying to apply two approaches. But when you do a real development, preferred is always recommended is lambda than applying regular functions. So here you just say x comma y here, okay? Something like this. And comma, just pass, but of course here we need to take the list here. Just take this simple list here. Okay, let me just do one thing. Here pass it. Sorry, pass this here. And also one more thing is we can remove this. This is not needed. Now this is the idea. Let's print this. What would we get here if you have something like this? Generally, we should apply a kind of addition here, addition or subtraction, because that gives you cumulative output. Okay. So what we do is first convert this to a list first of all, list of something, reduce of lambda of this, and finally what do you do? Print reduce result. Okay, and then just run it. Just check for the third output. Okay. So this is how you are getting something. And you can see implicitly the structure is it is managing something really different, just an FYI for us. So generally here in these kind of scenarios, we just need to apply x plus y. Okay, just remove this. Okay, when you are applying reduce. So what do you do right now? Colon x comma x plus y. Okay, fine. Yeah, we should be fine here now. Right click. Just a minute. What is the warning here? Expected iterable got int instead. Okay, let me run this and see if something we should change, will change it. We have closed this. Okay. Just a minute. I have a similar example with we just need to apply addition definitely, and we need to pass it. Okay, no problem. Let me quickly check with one small example.
If you remove that list part, it will work.
List we have already removed, right? Okay, okay. You mean this conversion? Huh?
Yes.
Okay. So now we are trying to print it. Okay, here we need to put one more closing brace. So this should be fine. Now run this. Oh, finally we got it. So this actually because, yeah, I got the point. Because reduce performs accumulated result, right? Again, converting that to list is not required, friends. We get one simple output, and the return type here is reduce returns a simple integer. So once after performing all this what we can say reduction operation, it returns a simple integer. So that's why when we converted a list, it is throwing error. So finally, this is the uh, idea like how to apply reduce here. So got it right, friends. So what's happening? We have group of values here, and we try to pass reduce, and those group of values are converted to a single value here. Simply speaking, you can understand how reduction works. So we have these many values. All those values are just simply converted to one single value. This is what the reduce does here. When you apply this, what happens? It simply converts group of values into a single output by applying what is that? This kind of reduction operation. Generally, this kind of operations you apply a lot on in PySpark or MapReduce. All this you split data into mappers and reducers and pass. Initially, it goes through mappers if it is MapReduce, and whatever chunks we acquire in mappers, that is passed to the filter. I mean reducers, and reducers simply reduce that data into an accumulated result like this, a cumulative result like this. So this is the idea about reduce, friends. Simple, quick analysis. Okay. Now, so we are done with the reduce as well. This is how reduce works. So group of multiple iterable values are converted into a single cumulative result. That's what reduce does. And important thing is just import it from functools. That's all. That is the idea. So reduce accumulated result. And this is a simple example. And again, we are trying to apply same thing here. Instead of plus, it is trying to apply a product. So you can try anything. It's up to you. You can just take this again, this example and try on reduce as well. So what you are, if you want to apply, see same thing. See here. See instead of plus, if you apply into, you might get a total different results. Here we are trying to reduce by applying addition. If you apply product, you might get something else. The result changes. That's all. You can see we got something applying product on all these elements. Similarly, you can apply minus, I mean division. Whatever you think you should apply on that data, you can apply. And finally, you get cumulative result. You can give a try on that too. So that is the idea, friends. Next, after that, so this is another example. Reduce applying using an initial value. So you can see here, you are taking a list and applying reduce. Let's just quickly test this now. You can also just choose start with 10 here. You can see here 10 into. So that initial value you can pass like this between that func value and function and this one, you can apply this 10. Maybe you can give a try on this. So because this is totally a little different scenario, you can take a list and you can take reduce. What you can do here, copy this and just come here and just change this. Okay. It is showing 10. What do you do? Lambda x comma y colon. And then you can say x into y. Let's try this example. So this is still throwing error. Of course, we do one thing. We can x into y. Okay, fine. Comma 10 comma. Okay, let's run this now and see. Finally, print result. run this. Let's see the output of last one if it is working. There is some error. Okay. So for this kind of scenario, this should work. Okay, let me see if we have another example here. Use initial value as parameter in, no problem. We can do one thing. Let's just quickly check on this. This scenario, okay? To func in a reduce example. Okay, let's say that. Okay, this should come as the last one. Okay, not. I think I put it in the middle. Small change then. So the position should change here. So list comma. Let's apply that here. So this is where the error is coming. The position of parameter. Okay, that's all, friends. Now right click and run this now. See, 1200, perfect. So slide correction in the PPT. Just change this position here. Just put it as a last parameter. So this works here. That's all. So this is another one. The initial values, it starts with 10 into 2 into 3 into again 4 into 5. You can check that just if 1200 is equal to all that doing product. So this is another scenario of reduce here, friends. Got it right. So that's all about higher order functions, friends. So hope you got that idea how this map works, filter works, reduces works. These are very really useful when you are working with PySpark and especially for interviews and also certification exams. If you are going through any certifications, generally, this is recommended, right? We need certifications for, having that visibility. So even there, these having a lot of weightage, higher order functions have a good weightage. So better to prepare this. So that's all. But these are simple to apply. Okay, this is fine. Finally, coming back to the zip. What zip does here? Simple. When you apply zip on two equal length lists, just it will merge. Zip will merge these two lists into one list here. That is list of tuples. Now converting to this to dictionary is much more easier. So by using two lists, you can create a dictionary by simply applying a zip. That is the easiest process. So that's what zip does. So this is another useful method. We apply this on multiple times where when you are iterating two lists together, two equal length lists, equal length lists of length, same lengths. When you are iterating them, even in such cases, if you want to iterate both together, you apply zip function. I'll show you all that one by one. So this is the simple example. What is that? Let's just apply this example here. How zip works. Maybe if you want, you can continue in the same, or else you can take a new file. So what do you do here? Trying to understand zip function. It is so simple. Suppose you, let's take multiple scenarios. Okay. Scenario one. So this is example one. Take two lists here. Suppose some L1 equal to, right? So otherwise, apple list, sorry, fruits list. They take an example of fruits list or anything, something like take a couple of values here, apple, some mango. Okay. And finally, one more is, so orange. I'm just taking three examples here, three values. And next scenario is prices. There is a price list. So apple is something like I'm taking a list 150 rupees per kg, mango some 200 and orange some 50 rupees, something like this. Now, what is that? I want to iterate both lists together. So how do I do? I can simply do this. What is that? By applying a zip sum f comma p in, what is that, zip of. Okay, you can directly apply. You can iterate both lists together by passing zip. This is one scenario. So here you can take price list, pass it here. This is one example, quick example, something like print f comma p. Okay, run this now. Just you can see here. You got it right, friends. You got apple 150, mango 200, and then orange 50. So you can do one thing. Why we are getting comma at this place? Somewhere, yeah, you can see this. Yeah. So now run this again. Now you can see this. So by applying zip, what you are doing, we are able to iterate two lists together without any issue. Suppose make a different length of list here. Suppose you put 60 here. Let try to run this, how it works. Still no problem. Length doesn't should not be a matter here because it try to iterate all that. How many ever are there in the I mean same length. So it try to iterate the first three elements in both lists. Suppose even though you add additional element, it seems like it is ignoring that. Suppose you have four, you have four here. Suppose you take some so another fruit like berry. Suppose you have three here. Let's see how this works. Even same thing you can see here. It is ignoring berry. So it is choosing the iteration until both lists are having similar length and the rest of that values, if anything is there, it is ignoring. Okay, it is applying still what? Still on apple, orange, and mango, and ignoring berry because that whatever is matching here, lengths are matching to that length, it is trying to iterate, and the rest of the values it is ignoring. So this is the idea. So next, what? Okay, another very useful scenario is creating a tuple from two differently. Suppose this is one scenario, iterating it together. Scenario two or example two, you can just name it as you like, friends. Okay, so you can take another example, example two. So what is this example? Same, you can keep same list here. The difference is you can apply some list three equal to, okay, list three equal to a zip of, what is that? What would be the exact thing when you apply? What how it look like when you apply zip? Fruit list, comma, price list. See here, and just pass it to this. Now print this list three here and see. Maybe adding a bit of fruits is best thing when you are merging. So it makes more sense later in the later part to just quickly understand. And just copy this and change that here. Okay. So that's all. Everything should be fine. Now you can see here we got zip option. So that zip, what you can do, you either you can convert it to a tuple or convert it to a, what is it, friends? List or anything of your choice. Suppose you do one thing, convert this to list. Okay. Now right click, run this. See here. So yeah, one more thing is I should close this here. Now run this. So see, perfect. See how beautiful this is. So here each value from both what is that? Both the lists, it is making one tuple. So first two values are converted into one tuple. Next two values are converted to one tuple. I mean, one from first list, one from second list. You can see here. The best thing is by merging like this, you can easily create best. This because this is something really needed. Otherwise, you can keep it like this just for analysis purpose. You can take this, copy and paste this same example and make it as example three. So generally, where this GIPS is really needed is generating dictionary from two different lists like this. Now I want to convert to the dictionary because most of the time we require dictionaries. We create dictionaries, right? So the easiest process to generate dictionaries, applying zip and convert it to dict like this, that makes more our job much faster. You can see here. So whatever dictionary I should create by doing some kind of processing or by adding a looping, all that, we can simply do that just by using zip here. And it just makes our job simple. Suppose I just ask you scenario four. Let's take one quick example. I ask you to generate dictionary by sharing two equal length lists. Okay, two equal lengths. Because generally, having equal lengths is always recommended. Okay, because we have to map each key here. Fruit acts as key and value acts as price acts as value. So in such cases, having equal length is always a best fit. It's fine. That is fine. Suppose instead of zip, you need to create a dictionary from these two lists. What is that you should do? You have to iterate. Suppose now we should create an empty dictionary, something like do one thing. Let me just show you. So the difficulty what we have by doing a process like this and applying zip. How simple it is if you apply zip. So you have to create an empty dictionary, change this to fruits list 4, and then I just quickly do this. I don't need much time. Now what you have to do, iterate. We have to iterate both of this. Even if you should iterate both lists at a time, then definitely we need to apply zip. That is needed. And if you want to create a customized dictionary instead of applying zip, what is that? For iteration, at least for iteration, we need this. What is this? Zip. So what you have to do again now, if you want to create a customized zip on your own, right? Come here. Here you have to choose this, iterate both one by one from each of these two different lists. So now what you have to do, you have to say some fruit lists of, so something like this. This is another way of creating dictionary. So copy of equal to put P and fruit list for just pass that here. Okay, this is the dictionary I want. And finally, what is that you should do? You have to just take this and then because these I generally keep doing it. That's why I'm trying to show you. Right click, run this now. And same output we get even for fruit list 4, same as fruit list 3. The difference is the treatment is changing. That's all. In the third case, we are applying zip. In the fourth case, we are going with a customized approach. So what is changing is approach is changing, treatment is changing. That is the difference here, friends. So definitely, instead of doing this, if we are really working in some development, you need to merge two lists into a dictionary. The best fit is the quick and easiest process is choosing zip. This is the quick idea, friends. Okay. So that's all about this zip function as well. So next after that, these are few examples. Okay, this is already done. We can skip this for now and then unzip with zipper. So this is another scenario. Okay, this is unzipping. This is a beautiful scenario again. Suppose you want to break down, you can see here a tuple into, you can see here. So convert all first values into one list and all second values into one list from a tuple or dictionary. How do you apply? This is the scenario. We use this. You remember this, right? Do you remember this asterisk thing, friends? We had discussed this. What is it? This is actually a variable length parameter. Unzipping is a simple process. What is that? You can just take this. What is that you can do? Copy this now. So, like how we zip, we combine merge two lists, unzip, break down one list into two lists. So that is opposite of what zip we are doing. That's what unzip does here. That's all right. So here, just take unzip, and then what do you do here? You just apply this zip of. So now unzip function, right? Just a minute. We apply zip only, no problem then. So zip off, we should pass one thing is we have to pass this as a variable length argument and just pass it as asterisk. Okay, then take two names, names comma prices. Okay, sorry, names comma vals. Put some vals. Okay, equal to something like this. It's a very simple process. This is unzipping approach. So we take zip and just pass this whole object, whatever it is, iterable as a variable length argument. And that's this zip just splits that whole object into two different lists, right? Or two different iterable objects. Now, what do you do? Just print names and then values together if you want. Probably these are returning iterables. We need to do conversion probably. Let's just quickly run this. Oh, yeah, no problem. It is returning. So finally, conclusion is we have two tuple outputs. So definitely, there is a say unzipping here. So we have two different tuples created. So if you want, you can convert to list. Not needed now. So even if the output is visible, then you can just keep it as is, no problem. And still, if you want it in a list format, then what you can do, then you can apply conversion this to a not that. I think we have to convert to individual level to list here. Finally, the output of this is we get two different tuples here, right? Extracting all first names from the this one zip data into names, all values into the values. So that is the idea. So if you want, you can convert this to list by directly applying list of names and here a list of values. Just right click and run this and see what would be the output. So it got converted to list here. This is the idea about unzipping process, friends. So that's all. This is all about what? All about this higher order functions. Probably we try to finish all this. So this should be give us a very detailed idea about map, filter, reduce, zip and unzip, all this. These are definitely very useful scenarios. That's why all these examples are included or curated into this. Okay. Next after that is we have to quickly talk about. So once we are done with this, we did close many things. So we have two more pending topics in functions. We have to close this and jump to the next topic. So probably we'll take up either modules or we take up either the other topic is files. Okay. So now recursive functions. What is recursive function? Let's quickly do this and then jump to decorators. If we can finish decorators, almost we covered each and every scenario topic in inside functions. We touch based everything. Okay. So let's do this now. This recursive. What is a recursion? Recursion is something a function calling by itself that we had discussed number of times. So we can just take an example and try that. Best example to understand recursion is by applying factorial or by applying addition, group of adding values like first n numbers. That gives you an idea. So how recursion works. And this is really useful. Even sometimes in my coding, I do apply recursion. In the recent times, just few weeks back, I tried to apply recursion by validating if so if a folder depth has some date or something, and if date is there, I want to uh, get all those paths, and that check has to be done recursively. One live example I'm just sharing with you. So that is where I applied recursion. But before that, what is here? Just let's understand quickly. Recursion means a function calling by itself. That is a recursion. Let's take a quick example. So you can create one more new file here. And before that, let me share all this what we discussed today. Copy this and where is this one? So here, let me share the code which we implemented today. And then after that, one more thing we discussed today. Same, everything is in same list, right? So higher order. One more is not this. I just created somewhere. Yeah, this one I believe. This I think we had this. I think I shared this yesterday. Okay, no problem. Mostly it should have there in that file itself. Fine. Now, next example is recursion. Let's take an example of recursion. Right click on new file. Just take it as recursion test. What do you do here? The recursion means best example. You take factorial as example. Df factorial. What do you do? You can apply factorial in two ways: non-recursive function and recursive function. So, what is non-recursive here? Let's apply two approaches. This is a non-recursive. This the logic is simple. This is a very simple thing. So, suppose you need to take a parameter here. So, that value you want to apply factorial or addition or whatever you want. Okay, product of first n numbers. So, if you pass 5, we get factorial of 5 or sum of first 5 numbers 1, 2, 3, 4, 5. So, now what do you do here? This is a non-recursive function applying factorial. Okay, so what do you do here? Simply you can take a variable factor, okay, and set it to 1. So you need a loop here for I in you can apply range, not a problem. Range of so you can try like n comma 0 comma -1. You can go forward or backward. We don't have a big difference here. Okay. You can iterate from n to 0 or 0 to 1 to n plus 1. Anything should be fine because this is a product, right? So what is the so fact equal to fact into I. So that's all. This is again a kind of doing a cumulative product here, like cumulative sum. We are doing a cumulative product. And finally, what you have to do, you just need to return this fact from the function. So you can try that here itself, return retrieve or return fact. So finally, this is the idea about non-recursive. Same thing we rewrite for recursive, simple. Non-recursive means there will be a frequent control jumps. That's what happens when you call this factorial function. Just see here, we can test case, apply new test cases. Test case 1 here, just pass. So okay, copy this recursive function, non-recursive function, sorry. Paste it here, just for pass 3. So, and assign this to print or some, okay, sorry, remove this colon. We are not defining function, right? Already we defined function here. Just call function, okay, and pass 3 in test case 1. So what is 3? 1 into 2 into 3. We should get 6 as output here. That is one thing. Similarly, just do one thing, just print it. You can assign this result back to some variable and print that variable or pass it to the subsequent operation, but just print it directly. Sorry, friends. You can take another example. 1 into 2 into 3 into 4. Okay. 2 3s, 6, 6 4s, 24 or something you should get here. Something like that. And one more just test case as you can pass 5 as well as probably should get some 120 or something. So this is non-recursive function. Let's quickly run this. Should be at 120. Same thing we just rewrite with the recursive now. So this is the output, right? So just rewrite the same function with that. So what is this? A recursive approach. So what do you do here? Simple. So all this is same, but remove this. This looping changes. Just to show you that difference, I am just removing this. So here What is that you should do is some fact equal to that n into, you have to apply a function called by itself factorial of n minus 1. Okay. And that's all. And here one condition check you should apply. Suppose if n equal to 1, then in this scenario, you should directly return what? Return 1. That is what you should do. Okay. Once n becomes 1, because this is a here instead of plus, you have to apply product if it is factorial. Yeah, you can apply plus as well. That is for getting cumulative sum. This is cumulative product. Factorial is nothing but a simple way of doing a cumulative product. A kind of reduction else just now we discussed, right? Some time back. That reduction we can do this with this kind of approach as well. Once if that n becomes 1, you should directly return n and you should stop that iterating stuff. So this operation has to stop. What is that? So you know what happens now? First it takes n, 5, 5 into factorial of 4. Again, same function is called by passing 4 as a parameter in the subsequent operation. Then again, it will be like this. The operation will be like this, 5 into factorial. You can see factorial of 4. Then what happens here? Then this factorial 4 again calls the same function from inside. You can see this is a recursion, a function calling by itself. This is a function call which is inside this same function. And this is a recursion. This happens till that n becomes 1. Once n is 1, factorial of 1, that returns directly a value 1, and that iteration stops here. That recursion stops here. So in the second scenario, what happens? You call factorial of 4 in this place. In place of factorial of 4, same logic is substituted, means what it gets here, something like 5 into 4 into, sorry, 5 into 4 into 3, so factorial of 3 you get here, something like this. Same continues. See, again, if you apply factorial of 3, what happens? Same thing. Just copy this. So just put it here. 5 into 4 into, just add 3. 3 into factorial of 2. And this continues till what? Till it is factorial of 1. Finally, it just returns directly 1. And we get product of all that. So finally, product starts from back to beginning. And we get the total cumulative product starting with 1 to 5. So that is what happens with this, what is it, friends? Recursive approach, right? So next, finally, we return this fact. So now what you can do is make this as fact 2 or recursive fact or something, and just copy these test cases one more time, and then just paste it here and just change this to factorial 2, which is a recursive 1. So, and then just run this now, right click and run this, and you get same output. But difference is the treatment changed again. So in the first case, it is a non-recursive. The second case, it is a recursive, and we have seen the tracing as well, how recursive works. And this is a quite clarity. Recursion is something which happens, a function call inside the function itself. This is a recursion. And difference is which is best approach. Generally, both are required. It's not like every time we apply recursion or every time we choose non-recursion. Majority of the times I see we applying non-recursive functions than recursion. There are certain specific scenarios where we need recursion. Both are useful data structure algorithms. So both are beautiful algorithms. You can choose whatever you think that is best fit to your requirement. This is idea about what is this friends, recursion. Same thing, same program, maybe instead of factorial, just change it as some sum or something. Just apply plus between this. Just change this to plus. Then you get cumulative sum instead of cumulative product or factorial. That is one thing. And change this initialization. This initialization, you have to set it to 0 if it is non-recursive. Here, you don't need to set to anything. It just takes care of that. So this is the idea. got it right, friends. So this is idea about recursion. And finally, we almost we are at the end of functions. One another major topic is decorators that we see in tomorrow's session. We just need 5 to 10 minutes overall to discuss decorators that we complete tomorrow and jump to the files topic probably or modules topic. So that's for today, friends. This is all about this one. Understood, no? So we'll stop here. Any more questions?